Saxon Algebra 1, Lesson 30. The first part of this lesson is really hard to teach, but it's not hard to learn. So let me explain. Algebraic phrases, that sounds creepy, doesn't it? As we go further and further into the world of word problems, we are faced with the challenge of taking words and turning them into equations that we can solve. That's the whole thing that makes word problems drive us crazy, is that we have to do this weird translation of words to numbers and symbols. So what John is doing is he's giving us some practice at that process before we get too far into actually doing the problems. He's baby stepping us into it. So what he has done in the book that is super helpful is he has created a list of a bunch of different phrases that might show up in a word problem. And then what he's done is shown us exactly how to convert these words to numbers and symbols. That's quite helpful. So the first thing I want you to do is get some sort of a bookmarking device. I highly recommend something like this, you know, the little Post-it flags. Oh, I got 2 for the price of 1. These sticky little dudes, and put it on this page so that you can easily find all of these phrases, and they will help you because, like in the practice set of this lesson, John gives you a bunch of these and wants you to generate this information. So this is a great resource for you to use, all right? If you don't already have some, I am a huge fan of Post-it flags. I have this kind that are the paper. These are the plastic ones. These are good for heavy duty stuff. Of course, I have them in multiple colors. I like the flags. They come in different sizes. They're called flags. But you can also use like this size too, just to put on the edge of your paper or the edge of your page. And that way you can easily come back and find some of these things. I don't necessarily expect you to write all of this in your formula notes. Just mark it in the book. It's too much to copy. You know what I'm saying? We don't need to make this harder than it actually is. I'm going to not review all of those phrases in detail because they're all there in your book. I am going to give you a few tips though. Whenever you see the phrase a number, let that equal n. N is the variable John likes to use for these, and I like it too because instead of using x, which just feels more random, when we see a number in words, that helps us connect to n because n, number, right, they match. We'll also see this phrase a lot, the opposite of a number. What that means is minus n. Remember that when we say the opposite of something, that is what a negative sign can mean. And spoilers, if you didn't know that, that is what it means. A negative sign is the same thing as saying the opposite of. Okay, so that is useful to us. Anytime you see the word sum, that means adding. When you see product, that means multiplying, which we can show with a dot, but a lot of times we'll use parentheses to show multiplication. All right, if you see the words more than or increased by, that means adding. If you see less than or decreased by, that means subtracting. All right, so as you get more and more familiar with these problems, this will become second nature to you, but I'm just giving you some kind of tips to look out for. And here's the last one I'm going to share. Twice a number Okay, we know that a number means n. Twice means 2 times. So twice a number is 2n. All right? These will help you make sense of these, and we will practice them before we actually start the full-blown word problems that require us to know this. All right? So John's baby stepping us in. All right, that's all I'm going to say about algebraic phrases. Like I said, when you go to do the practice for this lesson, you'll find a bunch of these listed. Use that information that you bookmarked. It's on page 125. You might just want to note that page number. That's the page that has that list on it. And that will help you. Use that. I don't expect you to know how to do those practice problems without referencing that list. Okay, now we're going to switch on to our second topic, which is our frickin' formula again. Oops. And this time we're going to be in decimal mode. So I'm going to explain to you again what frickin' formula is good for. Frickin' formula is really good for dividing up groups of things. So here are our Skittles again. They can be Skittles, they can be peanut butter M&Ms, they can be Reese's, they can be Mike and Ike's, or the tamales. What are those called? I don't know, the hot tamales. They can be Mike and Ike's, any kind of discrete candy that you like. Right? And we talked about how what we're doing is we're taking a group of things and then we're dividing it up using a fraction, 1/4, or what we'll talk about today, a decimal number, right? If this row represents 1/4 of all of these Skittles, which there are 20, in all, we can describe this little group as 1/4, or we can describe it as 0.25, because 1/4 and 0.25 are the very same thing, right? So we can use decimals to divide up our groups just as easily as we can fractions. It works exactly the same way. We adjust the frickin' formula to say d times of equals is, and we can prove our, and again, of represents the total group, is represents the special group. This is all the same as the fraction form. The only thing that's different is our lead number is a decimal instead of a fraction. So let's test it for this one. We would say that 0.25, this is our of number because it represents the special group, so times 20, and I'm going to use parentheses because the dot's just confusing with the decimal. That should equal our special group of 5. Let's see if it works. 0.25 times 20. We can use this trick whenever we're multiplying by a number with a 0. You can just make the 0 hang off and copy it down. We don't have to go through the hassle of multiplying it through. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5, and then we have to put the decimal back in. We count the number of digits behind the decimal in the factors. There are 2, and we put the same number behind, so we get 0.25 times 20 equals 5, and yay, that's exactly what our special group equals, is 5. So, yay, it works, right? So this is the formula that we will use. And again, it's just the frickin' formula with a D for decimal instead of F for fraction. But we'll practice using these. We're not going to spend a lot of time using the decimal mode. We're going to go on to the third mode, which is percent mode, and we'll use that one a lot, which is fine. So let's try some decimal mode problems. Ready? There are 3 of them. And remember, when we use frickin' formula, whether it's fraction or decimal, there are basically 3 holes, right? There are 3 places where we can fill in numbers. and John will mix it up. He'll give us any two of the three and ask us to find the third one. They're all equally, they aren't necessarily harder than another, the three different, depending on which hole you're trying to solve for. The algebra can look a little different, but it's not all that big of a deal. Okay, I'm going to copy down exactly the way John wrote the problem. This is 30.1. 0.32 of what number, and I'm just going to use WN for what number, is 24.32. Okay, we have to get our bearings. Here's our of number. Okay, so that's the mystery. Here's our is number. That's plugged in here. And then this must be the decimal, right? Even though this has a decimal too, we can see that this number goes with is. So this one is the one that we put in here. Okay, ready? So we're going to do 0.32 times what number, right? Because we're multiplying it by the of, is, now I'm on the is side, 24.32. Okay, so that's how we set it up. We identify each of the pieces looking at the words and matching. That's why this formula is so weird, is because these words are what help us find the number, because they're always together in the sentence. Okay, so here's our variable. We want that by itself. We'll divide by 0.32. And now we have to do a little bit of division-y division, right? Spoilers, it comes out cute. 24.32 divided by 0.32. Well, we have to fix our decimals first, right? We're not allowed to have decimals out here. So we jump it twice to get rid of it. So that means we have to jump this twice, and then the decimal goes straight up from there. Okay, so how many times do you suppose 32 goes into 2,432? I don't have a clue. I have to make that easier. How about we figure out how many times 3 goes into 24? All right, well, that would be 8 times. But I'm afraid that's going to be too big, because 8 times 3 is 24, but then we have to factor in another 2. So I'm going to try 7 times. That's my best guess. And let's see, I'm going to need that to go here, because then that'll go there, and then the bigger number will go there. 7 times 2 is 14. 21, 22. I subtract. That becomes a 3. 13 minus 4 is 9. 3 minus 2 is 1. And then I bring down the 2. Okay. 3 into 19. Well, 3 times 6. No, 3 times 6 is 18. So I'm going to try a 6. I also feel good about this 6 because 6 times 2 is 12, and that makes the 2 match up. And I'll scribble that one out and make another one because I'm carrying a 2. 6 times 3 is 18 plus 1 is 19. Oh, look, it came out even. John is a buddy and a pal. So these two equal 76. So what this means is that if there are 76 Skittles on the table and your grandma tells you that you can have 32 1/100ths of those Skittles for yourself, that means you get to take 24.32 of those Skittles. And I hope you have a very sharp knife and perhaps an electron microscope, so that when you're cutting the Skittles, you can cut 32 1/100ths of one of the Skittles and take it. Because if you don't, Grandma's going to be angry, and we can't have that. It took a lot to make my mom angry as a grandma, but, you know, unfair division of candy probably would have been enough to set her off. Okay, what decimal part, we can write that as what decimal of 42 is 26.04? That's the question John asks us. What decimal part, I guess I could put a P there. What decimal part of 42 is 26.04? Okay, so here's our of number. Here's our is number. And so this must be the mystery, right? Is the decimal. Now, if you want, you can use all 3 letters for your variable. That is absolutely fair. I used to think that somehow you couldn't do that. You had to just use 1 letter. That's what seems normal to me. But as we're seeing, you can make your variable have multiple letters if you like. 3 seems a little excessive to me. I'm gonna do one with just using a plain D, just to show you what that looks like. But you can use 2, you could use what decimal? Okay, so some mystery decimal times 42, right? Because I'm using my frickin' formula. I'm doing it with parentheses, because they can show multiplication as well, is 26.04. Okay? Just following this format once again. Now, in order to get my D by itself, I'm going to divide by 42. And now I have another division problem to do. This is what I don't like about the decimals. 26 divided by 42. It's okay to have a decimal in this. We just bring it up. 42 into 2,604, I have no idea, but I can do 4 into 26. That would be 6 times. I'm going to line it up like right here. 6 times 2 is 12. Carry the 1. 24, 25, right? And that becomes 84 when I subtract. Oh, 42 into 84, that's twice. I don't even have to multiply it. I know that's true. So my decimal number equals 0.62. And that's the right answer. John often puts a 0 before his decimal. That's okay, you can do that, but you don't have to. All right, fun. All right, so we have one more. We've had the variable, the of number has been the variable, and the decimal has been the variable, right? So guess what will be in our next one? The is will be the variable. The mystery. 30.3. And this is our last problem for this lesson, PS. 0.42 of 86 is what number? And once again, D times of, except I'm going to put it in parentheses, equals is. Okay? Again, I like to use the parentheses with decimals because the dot for multiplication is just confusing with the dot of the decimal. Okay, so here's our of number. Here's our is number. I like to do those first because sometimes the decimal confuses me if there are decimals in other numbers. But once I identify the of and the is, I know that this one has to be the decimal. So 0.42 times 86 equals what number? I'm just plugging in to that. And this is the easiest kind of all because we don't have to use any algebra to solve it. The variable is already by itself, so all we have to do is multiply 86 times 0.42. Right? And then we'll add it up. 2, 1, 6, 3, and we'll put in our decimal. Let's see, there's 2 digits behind. So there it is. So we say what number equals 36.12. So once again, if there's, let's say that you have 86 Skittles and you tell your little cute cousin that he or she can have 0.42 of the Skittles, you know, a little less than half because you're generous, but you know, Skittles are Skittles. And you're gonna need that sharp knife because that means your little cousin gets 36.12 of your 86 Skittles, which means you get almost 50. So I think that works out pretty well. Okay, and this is the right answer too. Have I been smiley facing my answers? I have not. Oh my gosh. This one's right, and this one's right. Yay! We got them all right. That's a good thing. Okay, so frickin' formula for decimals works exactly the same. We're just writing things out in decimals instead of fractions. It's just kind of like a stylistic difference. And like I said, we're not going to spend a lot of time doing the decimal form of these. We're going to move on. But we will be doing frickin' formula until the cows come home. Congratulations, you survived. Goodbye.